section 12.4, we're still doing geometric series, same as 12.3, except what happens when the number of terms is infinite. So if it's a geometric series and the number of terms is infinite, then the sum of all the terms, the sum, S, we don't even have sub n because it's infinite. The sum is equal to the first term over 1 minus r. Nice, elegant, easy formula. There's no, notice there's no n in this formula because n is infinite. This is the sum of the terms. Now, if, this only works if the ratio is, well, I'll write it this way. If the ratio is, basically, it needs to be between -1 and 1. Okay? Or another way of writing that is that the absolute value of r is less than 1. This is the same thing. These are equivalent. So because otherwise your sum is just going to be infinite, or either infinity or negative infinity. So if it's not, otherwise you say you don't use the formula, and you have to know to not use it. Otherwise, series has no sum. No sum, and by that I mean infinite. So I'm going to do 3 examples using the formula. You have to be very careful to check that r is between -1 and 1. Okay, and then I want to show you where first I'm going to show you where the formula comes from. So I'm going to show you how this works. So kind of the proof is on page 820. So if we're looking at this, how this works is like this. Okay, so you don't have to write this down. If we're looking at this infinite, so this is like an infinite geometric series, a half plus a fourth plus an eighth plus a 16th. So what happens as S sub n for the sum of n terms as n increases? Well, if you're graphing it, you can graph the terms. So if you just add the first term, you just get a half. If you add the first 2 terms, you get 0.75. If you add the first 3 terms, you get 0.88. Then you get 0.94. Then you get 0.97. And what is it getting closer and closer to? The sum.
1.
Yes. So it's like a limit. It's like since it gets closer and closer to 1, we say the sum is 1. And we could find this by plugging a sub 1 would be a half, and the common ratio r would be a half as well. You're multiplying by a half each time, and if you plug that into the formula, you will get 1. And we'll do some examples in a second of using the formula like that. But I just wanted to show you kind of a picture of what's happening. And if you want to see where the formula comes from, down here, you start with the sum of finite terms. Okay, and then as n gets bigger and bigger, like a half raised to a bigger and bigger power, that term basically goes away. It becomes 0. And so since down here you can see it goes away, it becomes 0. So you just get a sub 1 over 1 minus r. And that's where the formula comes from. So hopefully you'll find that interesting if you're interested in higher levels of math. So let's look at how to now we're just going to use the formula. So examples, we will do 3, and it's going to say find the sum if it exists, which if you have to check, otherwise the formula doesn't work. Only if r is between -1 and 1. So you'll say like sum n equals 1 to infinity. of negative a half to the n minus 1 power. So I want to find the sum if it exists. It's actually, these are easier to do than maybe than it looks. All we need to use the formula, we need to know the first term, a sub 1. So you simply plug 1 into the formula, negative a half to the 1 minus 1. It turns out it's to the 0 power. Anything to the 0 power is 1. So our first term is 1. Our common ratio is what, you guys? Yeah, you're multiplying by negative a half. You can see it right here. So you use, okay, so does this formula even work? Is r in the right place?
Yes.
So I want to like say yes, check, we can use the formula because r is between negative 1 and 1. Otherwise, the problem is you could still like use the formula and you'll get an answer and you'll think you have it and it's not right because you shouldn't have used the formula in the first place. So plugging it in, a sum equals the first term over 1 minus r. It's a very easy formula to use. 1 over 1.5, which is 3 halves, or 2, you know, dividing by a fraction is the same as multiplying by the reciprocal. So it's 2/3 without taking out your calculator. This is 1 plus a half. 1 plus a half is 1.5 or 3 halves. Okay? Any questions on that? That's the sum. You would get 2/3. If you expanded this and you kept adding it forever and ever, you would get closer and closer to 2/3. So we say the sum is 2/3. Okay, let's try this one. You should like these. These should be the easier ones. N equals 1 to infinity of 3 times 5/4 raised to the n minus 1 power. Okay, so so before we even do this, well, let's just look at r. What is r here in this equation? Yeah, is 5/4 between negative 1 and 1? Well, 5/4 is 1 and 1/4. It is not. So no. And you would stop right there and you're just going to say no sum exists. Okay? If you were to start writing these out and took the partial sums and added, you would see you would either get infinity or negative infinity. Done. Number 3. Last one. Let's say we're given, instead of in sigma notation, this is called sigma notation. If we're just given the series listed like this, like the first few numbers, and then it says dot 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 plus dot dot dot. Okay, that's still an infinite geometric series. It's just in a different form. And now a sub 1 is really easy to see. A sub 1 is the first term. It's sitting right in front of us. The ratio, well, it's not obvious what you're multiplying 3 by to get 3/4. Maybe it is. But remember, your default when you're trying to find r is take any term like 3/4 and divide by the previous term. So if you did 3/4 divided by 3 over 1 is the same as times the reciprocal, which is 3/12 or 1/4. So that's r. So now you plug it in. S, the sum of all these terms is a sub 1, which is 3, over 1 minus, the ratio is 1/4. So that's 3 minus, what's 1 minus a fourth? 4/4 minus 1/4 is 3/4. So you're multiplying by the reciprocal, and that gives you 4, because the 3's cancel. And that would be, that's what all that would add up to if you went on and on and on forever. 3 plus 3/4 plus 3/16, etc. You would get 4. And you could even try it out on your calculator. You could start adding up those numbers, and you would get closer and closer to 4.